Okay, so we are off to the races here. We're gonna do 6, 7, 8, 9, and then we'll dip over and do some more questions in the double digits. We might not do them in that order. I'm not dodging questions. I just want to do them in the order that I can process. Psychologically, we can do the most questions as possible. So if I were to do one of the really long questions right now, you'd be like, "Oh my goodness, we're gonna be here all day. How are we gonna do 8 questions?" So anyway, question 6 is a short one, and it's a nice one because it's a pattern that we've seen a few times in the course, and it uses skills from geometry that we've seen before. So in this diagram here, we have a circle that is connected to two tangent lines. So these are tangents here, and those tangents, remember, touch the circle at one point. And the question here is to find the radius of this circle for this particular arrangement. So it's a permutation of a question that we saw earlier, but the main idea is, if we're going to use trigonometry, where is the right angle triangle? And you'll forgive me, hopefully. I'm not going to do too much question and answering here. I'm going to just base it on my experience, the explanation. So I'm just going to try to be more efficient today. So here we can draw a perpendicular, which is basically the radius. The radius and the tangent, remember, they meet at a right angle. So there's a secret right angle there. And also using the angle bisection, bisecting means cut in half. That's right, you get the two triangles in there. So there's that triangle. That's the triangle we need in purple. So this angle here is half of 64, which is 32. A few more things to talk about, and I think that we're good to go. So let's just zoom in here for a second. This is R. This is R, and this is 5. So if I go off the diagram and I draw a nice clean triangle, we have R, R plus 5, and then this little angle that's tucked in here, that's 32 degrees because it's half of 64. From that point, we have a formula involving SOHCAHTOA. So here we have 32. Remember, that's opposite. And this, of course, is the hypotenuse. So we have sine. So sine of 32 is equal to R over R plus 5. That's the question, people. Not every question in this booklet is a marathon. This question is so short and sweet. Look at that. You get a triangle, you write an equation here, formula, whatever you want to call it, and then you solve it. I don't care if you make this a decimal right away or whatever you feel like doing. What I will do, though, for the sake of efficiency, is since this now becomes an algebra question, I'm going to copy and paste my answer, and I'll give you this answer on Blackboard as we finish class today. So just bear with me as I'm going to be doing screenshots and dumping images onto the file here. So there's my solution. Just a second, I can't see the chat because I'm on a different tab. So I'm just going to put that right there. I don't think we can cover the question for a second. Denny, what's up? That's right. You can do a little bit of cross multiplication there. So I'm going to follow Denny's lead there, and I'm going to just point out that I turned the sign into a decimal. See? Right there. Now, if you're wondering how many decimal places, don't get too stressed out about that. The question says 3 decimals here, so I figure if I go with 4 decimals, I should be good. That's not the proper way to do things. You should be thinking about significant digits, but it should be okay. Hi, Malik. So we have that number there, and then what we're going to do is we're going to cross multiply. Remember, this is over 1, so we do this times this and this times this. So 5299.5299 times R plus 5, and then we do 1 times R. So at this point, once you have this, we can distribute the R into the bracket. So that's that times that is right there. And then 5299R times 5 gives you this. And we start to get into something that's very nice, clean, A nice little linear equation. Yeah, the more decimals, really, the better anyway. And finally here, we can move this r over. So what I did there was if you're wondering how I got 4701, I did 1 minus 0.5299. Not the r, there is an r there. I'm just talking about how I got this number, the coefficient there. Finally, to get the answer, I'm going to divide 0.4701 by this number here. Sorry, the other way around. I'm going to divide 26496 by 0.4701 to get this answer. So that's question 6 there. I went a little bit quicker on that one. Perhaps I confused myself with my my numbers here. But the main thing is just be careful with setting up that first step, because that really is the centerpiece of the question. So a nice question to break the ice with you. The next question, number 7, is a marathon. Not a marathon, but it's probably the longest of the questions. Yes, there's always a 1 in front. In this case here, it's understood that there's a 1 in front of the r. You're welcome. So we're going to go to question 8, and then with time permitting, I'll go back to 7. Whether or not we cover 7, it's not going to interfere with your learning. And also, I think 7 is probably a question that's too long for a test anyway. So we're going to go to question 8. I think you're going to like question 8. It's clean, it's simple, it's elegant. So let's go to number 8 here. So we have this configuration. It looks a little bit intimidating possibly, but look at that. There's a rectangle right there. And then we have this L or T shape that kind of is touching the point A here, and then is also interacting with C. The question ultimately is to find the value of the length x here. Now x is from here to here, so x is AF. So how are we going to do that? Well, it would be helpful if we introduce some intermediate variables. So what I'm going to do is put a different diagram, just a modified diagram that will assist us in this process. Actually, Denny, if you do that, I think that it might introduce a bit more work, but I'll show you, hopefully when I show you this diagram, it'll give you a clue about what to do. So this question is, I'll just put it right beside it. So what did I do there? I wanted to introduce the variable y. So on this upper edge here, from D to G, I introduced the quantity y. So this is y here. Also, if we play around with the angles, this angle here is 20 because that's a right angle. That's 90 degrees. So that's 20 degrees there. If you want to go further, there is a right angle here. Since that's a right angle, there's a right angle there. If this is 20, then this has to be 70 also. You can also argue this is 70 because of the Z law. There's that Z law that we've seen in the beginning of the course, like that, 2 parallel lines. This is a rectangle, so those are parallel. So now we're kind of rocking and rolling here. We have the y here. And also, if this length here is 8, that's 8, and this is y, then the leftovers has to be 8 minus y. So that's the heart of the question. And now what we have is a process where we can go and get y, and then we can get 8 minus y and get x. So I'm going to label some stuff here. So this triangle here, perhaps I should just put a 1. That's triangle number 1, and that's triangle number 2. And not so tough. So one more thing here, that's a 5. Remember, if this is 5 here, this is also 5. So if we take a look at triangle number 1, we can safely say that we have SOHCAHTOA. So we can do here, we can use the tan of 20, and I'll do the screenshot of my method. If you don't mind that I'm doing these screenshots, it's because I'm trying to minimize the amount of time I start using the stylus, because sometimes the stylus doesn't catch well on my screen here. Good morning, Matthew. So I got y here by using tan. Now, if you're like, why is it tan? Like, if you're wondering, why the heck is it tan? Here's my triangle, and there's a right angle. And if this is 20, then this is opposite, and that's adjacent. See? Opposite and adjacent. So hopefully that assists you with getting past the first hurdle. The neat thing about this question is you can also use similar triangles to solve it. You don't actually have to use SOHCAHTOA at all. You could use similar triangles, but you might end up with a system of equations. And in reality, I do think you need one SOHCAHTOA step. So what I'm saying is the way that I'm showing you is probably you could do it with less SOHCAHTOAs. And that's right, Denny. It's tan 20 times 5. So that's tan 20 times 5 right there. And that's how I got this number. Very good. Yeah, SOHCAHTOA is better. If you, I honestly, people, I have some questions with similar triangles that will make your head spin. They're not, just because you hear, some people hear similar triangles and they think, oh, it's a joke, because you did it in grade 8 or grade 9. But it's not. You can do some really nasty questions with similar triangles. Anyway, let's take a look at triangle number 2. In triangle number 2, no, we're not trying to be heroes here. We're not trying to impress anybody. So we're going to look at triangle number 2, and you can see here that if I examine the sides here, here's 70 degrees. Then this is opposite, and that's hypotenuse. So what do we have here? What's opposite and hypotenuse? Is that sine, cos, or tan? That is right. It is sine. Okay, so we have sine 70. This is why I like to copy and paste the pictures. Sine 70 is x over 8 minus y. Yay, look at that. That's kind of scary, but don't panic right away. See, you know what y is. You can just plug in y right there and you're good. So that'll give us a very similar equation to the previous one. So if you don't mind, I am going to drag and drop in a second. So I'm going to drag and drop my answer there. So there is my method. Trying to get it on one window there. So we have here, let's walk it through slowly. In fact, that first line of writing, we don't really need it. So let's just get rid of it. There we go. That looks pretty. So we have here 8 minus y, but y is 1.8199, and you get x over 6.1801. And then mathematically, it's the same thing that Denny mentioned. If you have these two guys, you multiply. Same idea here. You multiply those two guys. There it is. They're multiplied. And you get your final answer, which is 5.807 meters. Look at that. Cos 30, cos 20. You could use cos 20 ramp. Yes. Not 30/20, right? Cool. Wow, that's the first time I've had applause today. I'm very pleased. Thank you, Matthew. That's yeah, you can use any of the angles. I'm not going to show you the solution with similar triangles, but it doesn't really matter. Like, honestly, people, I'd love to show you some similar triangle questions from math contests, but you know what? That's just I'm just asking for trouble. I'm asking for trouble. More applause. Wow, I'm flattered. Okay, Let me know in the chat. Are you ready to move on to another one? Who's ready to move on to another one? All right. So before I do the next question, some people might be like just getting some more things on paper. Remember, you have an assignment due tonight. Don't forget that, okay? I checked Blackboard, and I saw that I got about a dozen people so far, but there should be more like 40-something people. So make sure you get that assignment into me before midnight. Okay, so let's go on to a question involving the pentagon. Yeah. So before we dive ourselves into this question, we've actually done a question just like this. If you remember, I don't forget about intercession week. If you go back 2 weeks ago, what I mean is 2 school weeks, not the week that we had off, you'll remember that I showed you a challenge question at the end of class, and it was on a Friday. Yeah. So we've actually done this question. That's right. Thank you for remembering, people. So what I'm going to do is I'm going to I'm going to talk about how we did that one last time. So let's talk about, but this time I'm going to use pretty pictures because I have nice diagrams in my personal notes. So the question here is this. We have a regular pentagon. So for those that are a little bit rusty, the word regular means that all of these sides are the same. And I have conveniently shown you that you could chop it up into 5 triangles. So we can have 5 triangles. So what we're going to do now is we're going to find the area of this entire shape by finding the area of one of the triangles and then multiplying that by 5. So here's our strategy. We need the area of the triangle, and then we know that the area, the final answer, I'll say area penta or pent or whatever you want to say there, is going to be 5 of those triangles. And that, my friends, is how you rock this question. So let's talk about some pictures. Now, you see the hint here, split it up and do some stuff. If you don't mind, I'm not going to get rid of the hint because I don't like you, but I need the space. So real estate is at a premium in this course. So let's get rid of that information there. I'm hiding the evidence. Never happened. So first we're going to consider the isosceles triangle, and then this is coming from my personal solution, so it's going to look nice and pretty as I drop them in the file. Just a second, people. I'm doing. What happens is the more of these you do, the more pattern recognition it is. So there's the picture of cutting the triangle. And now we're going to just mention quickly that angle there, that little angle at the top, that angle right there is 72 degrees. And if you're wondering why is it 72 degrees, keep in mind here, this is 360. If that's 360, then we divide it by 5 to achieve our target. Yep. Now, next step is to cut this triangle in half. So I'll say it professionally, we're going to bisect the triangle. So there's the triangle as we cut it in half, and that's theta right there. So let's talk about that triangle in more detail. I'll just draw the triangle over here. I gotta tell you, when I'm teaching your class, for some reason, my computer and my stylus, they work beautifully. But when I teach the other students in the degree program, for some reason it's slow and I can't write things fast. I think it's a couple of things. I think it's because you guys are good, but also because all the issues I had with the internet, with my building, they were doing construction outside. So I think that the universe is paying me back in a good way now. Anyway, who knows? The voodoo is strong, yes. So we need to find the height of this triangle. We need that height. So how are we going to find that height? How do we find that height, people? Are you sure it's tan or sine or cos? Which one is it? It's either SOHCAHTOA. You choose. I got a sine. I got a props back, but I can't use my emojis. You're gonna have to bear with me because props. I gotta scroll, and I'm probably gonna run out of time. Oh wait, I found it. I found it. Hang on. There it is. Yeah, it's tan. Thank you, Denny. My stall tactics. I was trying to find a prop symbol to appease the masses here. So anyway, here we go. So there's the height. I use tan here. Awesome. Awesome, awesome, my friends. Look at that. So let's take a look carefully here. We have 3.5 over h. So see, the variable is on the bottom. When the variable is on the bottom, remember that it's a division that will get you to where you need to get, which is, in this case, to find the height h. But we're so good now. If that step is done, the rest of the question is so smooth now. So now we can finish up here. We know that the area of this triangle, so this triangle here, I'll just circle it for us. Whoops. Maybe I'll just kind of do this to it. Give it a little bit of a, really? There, it just glitched for a second. We know that it's half base is 7, and the height is that h value, which is 4.8173. And don't worry, I've typed it out earlier. That's 16.861. And that's in units of what? What are the units for the area here? Anybody in the chat? What's the units, people? Meters squared, yes. Don't mind me, I'm sipping a little bit of my hot cocoa. I'm having hot cocoa this lovely morning here. So there we go. That's the area of the triangle. Yeah, it's meters squared, yes. So let's get that pentagon, and then we're good to go. Tom Brady just signed with Tampa Bay. Oh, goodness. All right, so I was going to try to copy and paste it, but it's not. There it is. It wasn't being my friend for a second. I was getting upset with my PowerPoint presentation here. Whoops. Let me redo that. Just so everybody knows here, today, you know how I post the lesson on YouTube right after class? Today I do have an appointment, so I won't be posting the video until tonight on YouTube. But this video is not needed for the assignment. Thank you, Denny. So if you see me not posting the video right away, I'm not trying to make you watch a video on a Friday night or anything. I put 30 here, okay? So the reason I put 30 is because I had extra digits on my calculator that I didn't really show you on the PowerPoint. Well, very kind. Thank you, Matthew. Yeah, and you know, I hate giving you assignments on Fridays, but you know, this is the one thing I never understood is that I don't like doing, I don't think it's a good idea to have a double-hour math class on a Friday or a Monday. And there's many reasons for this. I think Monday it's good to have a 1 hour class, but there's also the issue of long weekends. There's also people that have religious observances, and I don't want anybody missing school because of any days that are statutory or observational reasons cannot attend school. Yeah. Plus, it's Friday. So I hope that you had a good experience with that. And definitely, I agree with you on the chill side there. What we're going to do now, we're going to take our time now and do question, I think it's number, let's see, which one did we skip? We're going to we'll do question 7. 7 is a pretty long question, so I don't want you to get too scared. but it's a long one. So can I skip over? May I skip over to the next question? Are we good to go? Okay, so this question, thank you. Thank you, thank you. So this question, it has some hints here. It says, okay, first of all, we're trying to find the angle theta here. Now, you're looking at theta. Don't get too detailed on the numbers, but look at this. I've never seen an angle measured like that. 20% each day, yeah. I usually give my 50 on Wednesdays, Denny. So this is theta here, but what you need to imagine is that this line here extends. So the angle theta refers to this angle overall, okay? It's called a finite angle, but the thing here, it says deceptively tricky, don't extend. Now, the author of this question is very, very, very talented. Um, I chose to actually extend the line. So if you don't mind, I'm going to contradict the advice here, but you don't have to extend it the way I'm doing it. So it says here find theta. I'm just going to get rid of that as well because we don't need that real estate. We need to use it for something else. So that's what we're working with. So to assist us with this question, I'm going to put a diagram up, and yeah, it's going to scare some people because it's a lot of writing on it, but it's for your benefit. So this diagram is what I use to solve the question. We'll do this question. It might take us a little bit of time, but then I promise you after this, I'll give you a nice break, and then we can go and do the other 4 questions. Yeah. 7 is like 7 is a question that if I was an evil person, I would give you on a test. I don't know that. Have a cocoa like me. So anyway, that's very kind. So let's take a look here. Just follow me through the question so we can make sense of what's happening. So this angle theta here, I've written it in the corner here. It's the same thing. What's the next thing I did? The next thing I did is I noticed that, okay, this is 16.5 meters. So this height here, right here, let me actually let me do it in red or something, or pink or whatever. That's 16.5. You with me so far? That's 16.5. This height is only 10. So these heights are not the same. So what I did was I drew a line across to form a rectangle. So I'm going to do this until I get it right. There's a rectangle. Let me shade it in yellow. So this yellow thing here, this yellow shape, is a rectangle. And it's also a rectangle right here. So I kind of did the question like I was playing with Lego. I broke it up into little pieces like a jigsaw puzzle or like a Lego set. So now we're able to find that height h, because the height h, as Denny's alluding to, if you want to find h, perhaps I'll use blue here. If I take this number here, this quantity, and I subtract this quantity, that gives us h. And that's the first thing. That's the first thing I did. Sorry, my bad. I apologize. H is 10.38. Excuse me for that. Sorry. I was getting ahead of myself. Thank you, Ram. Exactly. Ram is exactly what I was trying to say. If you're wondering why do I mix up my stuff sometimes, I'm looking at 2 screens, a chat, and a PowerPoint at the same time. So I'm doing 4 things, but I'm only one person. So, so if we want to find x here, we can take this number and subtract them. So what I'm doing is like a checklist. I'm checking off the things that I need. Also, we know what R is. R is good. It's literally right in the question. See, this is R. So that's good. So let's talk in more detail about what theta is and how we're going to get there. Notice how I have 2 triangles here. Let's really zoom in there. See these 2 triangles? Let's call this triangle number 1 and triangle number 2. Those triangles are right angled. This is a right angle because we have a rectangle at the bottom. This is a right angle because of our first example today. It's a circle tangent theorem. And this is the key to the question. This angle here, draw it really slowly, is the same as this angle here. And that's because of the parallel lines and their associated theorems. So you see that. Who remembers this property back in somewhere in geometry? This is called corresponding. So we have corresponding angles. So that's actually the key to the question. If we can get theta 1 and theta 2, then we know this is our last step right here. Theta equals theta 1 and theta 2. That's the key to the question. So as your comments are very excellent, people. I'm patching together what people are saying. They're saying to find h, to do the sides, to go into the triangle, to get the angle. These are all good comments. So what we're going to do is we're just going to propagate through the question and get our stuff. So here I'm going to start to drop some of my solutions into the page here. And you'll have to forgive me because I'm going to be jumping between two screens. But after we do this question, I think you're going to be in the clear. So first things first. We're not solving for this stuff. I think it's evident that everybody should know this from the diagram. R, H, and L are given. Those are given to us. There's no issue there. We know R, H, and L because they were actually straight from the question. I just, sometimes when you have all these numbers on a figure, 10, 16, 48, whatever, honestly, when you go to this diagram and you start writing numbers everywhere, I don't know if it's you or if it was just me, but I get annoyed by all the numbers, and I'm afraid that I'm going to screw something up by putting a number in the wrong place, which I actually did in my explanation. I said H instead of X or something, or X instead of H or whatever. But when I use letters are so clean. When I use variables, it's a lot easier to process. So I advise you, if you get intimidated by all the numbers everywhere, just put letters, put variables. Anyway, we know RHL. The first thing that we got, and I think I forget who had said it. I think it was I have a feeling it was Ram, but I don't remember. So I think it was Ram. That's right. So the first thing I got was X. So there's X. There's your first step. Okay. So the first step is to get X, and that's just equal to 6.12. So now we know this quantity here. We know this quantity, and maybe I'll use a really skinny pen here. That's 6.12. We also know this is 48.75 because that's L. And the units are all meters here, but I'm going to run out of space writing units on the diagram. Any thoughts on what we should get next? What do you want to get next? So you want to get theta 1. So when Ram said tan, they're referring to theta 1, okay? Because you can do theta 1 is tan inverse of those. So I have that somewhere in my I have all the little steps on my screen here. So I'm going to write down that step right now. Now, don't panic when you see this. It's written sideways, but really when you look at it, it's nothing out of the ordinary. I've just decided to kind of write it in a left to right fashion. So theta 1 is the inverse tan, so it's this thing here, tan inverse. Because you're finding the angle, Denny. You're finding the angle. So you're starting off with this equation. tan, whoops, tan of theta. Yeah, because when you're finding an angle, it's an inverse. Thank you. So that's the reasoning, okay? Good class, people. Good class. Very good class. Okay, Ram, you went to find the other angle. I'm gonna say that that angle that you found there, Ram, you don't really need it. We don't need that angle there, but we do need y. We need y. So how are you gonna get y? Well, you could use anything you want actually, but I'm gonna use the Pythagorean theorem because hey, nothing wrong with going back to basics, right? Nothing wrong with going back into the sand pit and playing with the sand a little bit. You don't have to be all fancy. There you go. So we're just going back to our basics, my friends. Look at that. We just drop a y there. So we're on to some more skills here. So everything that I've done here so far, this whole thing here, this phase of the question, was dealing with triangle number 1. So now we're going to move on in our lives to triangle number 2. It's okay. We're almost there, guys. We're almost there. All right, let's go to question, not question, sorry. Let's go to triangle number 2. All we need is that angle theta 2. So let's look at the diagram. Do we know r? Yeah, we know r. Whoops, let me use that skinny pen there. That's 16.50. Do we know this length y here? Yeah, we do. I'm going to put a happy face there. Actually, forget the happy face. Let me just put y there. That's 49.133. So yeah, we're good to go. And this question definitely involves sine now. Thank you very much. So we're on to triangle number 2. Triangle number 2 is a one-stepper. So I'm just going to drop my answer in there. I have to tell you, you know, some things about working online are very annoying. Like one thing is I don't get to see you in person and we can't joke around in person. We still can have fun though, obviously. But I'll tell you this though. Doing this question online is actually easier than doing it in person. Because this question I probably use a couple boards. Like I use a lot of the like those we have the whiteboards and I'm just all over the place with the markers. So anyway, there's theta 2. I use sine. So if you're wondering, whoever was asking before about inverse, remember you're finding an angle. So when you find an angle, you got to do inverse. And hopefully that makes sense. Let me just put that up here. I'll move this guy over here. And just to support people that are, yeah, you could definitely hit those recordings as well. So tan theta 2, and then we have 16.50 divided by 49.133. It's kind of funny because when I actually made the channel, and I've been putting videos up since last year, the whole channel, the whole YouTube stuff started with me trying to help my niece out because she lives far away, and I was trying to help her with math, and then I just made some of the lessons I did for her, like I just made them public. I was like, okay, let's make them public, and all of a sudden, I'm getting emails from people all over the place saying like, oh, that helped me or whatever. So it's good. It's good that it helps people. All right, what's next? What do we do next, people? What's going on? That's next. Now you can add those together and you're good to go. Yeah. So I have a decimal quantity there. I'm just gonna put on the screen here. Just trim it down a bit. So there's the final steps. Remember the question, although I kind of removed the wording of the question, you need to write the answer in degrees and minutes. So that's just one last thing to focus at the end on. But this answer is the answer, and then this answer is the preferred notation for this question. So yeah, there you go. Not so strong. Not so strong, the Kung Fu. Ram, I'm gonna lean toward questions that are not so intricate. I don't like asking questions that are marathons on tests. I think what you're gonna see on your test, well, there's a lot of reasons for it. You can imagine, right? It's really hard to mark, and it's also really hard for me to allocate time for you on a test. So I plan on giving you questions on your test like I did on the first test. Let's just say there's 7 questions. Yeah, yeah. Unfortunately, due to constraints beyond my control, I do make the test 1 hour, as you know, 1 hour and a bit. But anyway, it's 10:44. I'd like you to go take a break, clear your head, do some yoga or whatever you need to do, and we'll meet up again at 11. Okay? So let's meet up at 11. Here's a mathematical pattern that will be valuable to the subsequent questions. It's basically a ratio that involves a square and its diagonal. If you have a square, and let's say that the side lengths are 1 and 1, then the diagonal is root 2. That's all. That's all I'm trying to say with this page. Now, what's going on over here? It's a bit more advanced, but it's saying the same thing. In other words, if you have a rectangle, I'll just draw it here as well, and it's, sorry, a square, and it's A and A, then the diagonal is A times root 2. So it's A times, that means A multiplied by root 2. So this is the pattern that we're going to use for some of the upcoming questions. Why is this A root 2 and A? Because this triangle is similar to that triangle. They both share the same set of angles. And because of that, if I multiply this side by A, then everybody else is also scaled by A or multiplied by A. So that's the reasoning for that. So bottom line, we're going to use that pattern in a question or two for sure. And hopefully you find it easy to do, because it's just one pattern that unlocks the next questions. So if we go down to question 14, here's 14. And let's try to figure out how that pattern would allow us to solve this question. So I'm just going to put the pattern over here. And I'll put here A, and then we have, I'm going to put it this way. I just feel like putting it this way. There's a reason for it. And that'll be A times root 2. A times root 2. So the question here, what is the largest size of pipe diameter D that you can fit inside this quarter circle? So this shape here on the outside, maybe I'll just highlight it in orange for a second, that is a quarter of a circle. And then we want to fit a pipe, so that's this thing here. The pipe is this circle right here. So the question is, what is the largest diameter pipe that you could fit in there? It's a little scary, but forget about scary for a second. I promise you, once you see the setup, this question is actually really short. This question's practical. I really want you to feel me on that one. It's a practical question. Imagine that you had an irregular cross section of a wall and you wanted to fit a conduit through it. It doesn't have to be a pipe. It could be anything. It could be pipe. It could be duct work for ventilation. Doesn't matter. I'm pretty sure that there are people in this audience that have installed or are familiar with ductwork or other conduit within cross sections of walls. The idea here is to fit that cross section of pipe, that pipe through that cross section, and it comes down to this pattern. This pattern will reveal the answer. So here's the thing. I'm going to draw a straight line, and I want you to tell me how long it is. It's a ridiculously easy question, I hope, but I'm still going to ask it. How long is this? How long is this purple line segment? In the chat. What is that length? It's not the diameter, because the diameter stops here, doesn't it? This part here at the bottom does not belong to the pipe. Yeah, it's the diameter plus the outside part. But a more simple answer, thank you, Zifeng. The answer is 5. That is 5. Do you see that in the crowd there, everybody? That's 5. Because it's a circle. This orange region, these are all 5. These are all 5 because it's a radius. But now what we're going to do is kind of where Shalon was going with this. We're going to take that and turn it into smaller pieces. So this is the part that gets a little bit scary, but it's not too bad. So remember, I'll do it in yellow. The yellow thing here, that's 5. So far, so good. That's 5, okay? I'm going to highlight some stuff now. How much is this? Just that. What is that equal to? It's not 2.5. Remember, Denny, that if this was 2.5, let's just go with that argument. Then this would be 2.5, and that'd be 5. But then you have leftovers. So that wouldn't make sense because they have to add up to 5. So that length there, this length there, that's less than 2.5. It's actually shorter than 2.5. What it is, though, is as follows. If we have a pipe of diameter d, I'm just going to say that the radius is r. So just bear with me. I'm going to call the radius of that pipe r. There, little r. So that pipe there, that's r. We don't know what it is. It's r. We actually don't know what the value is. We do know that the radius is less than 2.5. We also know that the diameter of the pipe is less than 5 because it has to fit into this wall or cross section. Okay, so far so good. How much is this length here? How much is that second length down there? It's not r. It's more than r. It is 5 minus r. You are correct, Zifeng. But can we use something different? And this is the key. I'm going to wink at you now. Wink, wink, okay? Here's a big wink. That's my clue. That's the clue I give you. Here's the answer. We're going to use a really thin pen here. How much is that? How much are all of these pink line segments? Yeah, they're all R. Thank you, Zifeng. Very good. Those are all R. So how much is this? What was the pattern I was talking about 5 minutes ago? What's this length here? It's the pattern right here. It's this thing. It's R root 2. It's R root 2. Do you see that? So that's good. So let's summarize here. Because I got a lot of colors, and the colors are really distracting me. So let's talk about a summary here. This thing here plus this thing here, whoops, what do they total? What's the total? That's right, it's 5. That is correct. Congratulations, Denny, you just set up the equation. R plus R, actually I'd say that's a combo of Denny and Zifeng, so very good. R plus R root 2 equals 5. That's the formula you have to solve. That's the equation you have to solve, people. And once you get R, I'll just say here, get R. And once you get R, then you know the diameter to finish the question is 2R. You just double it. My friends, that's it. This question is toast. What's root 2 as a decimal? Well, last time I checked, I think it's 1.414. Root 2 is one that I have in my brain somewhere because I use root 2 a lot in a lot of different areas of math and physics. So can someone do that on their calculator? 4142. Yeah, I need an extra digit. Thank you. Let's put an extra digit there. Okay, help me finish this, people. We're almost done the question. It's over before you even realize we started. So we have 1R plus that. So we have 2.4142 equals 5. So the answer for R is, please confirm. I got 2.071. Thank you, Liban. 2.071. Units are inches here, and then the diameter, you just double it, right? So double that. I'm just doubling in my head right now. 142. Yeah, that's right. R is not that. R is equal to this, Shalon. You have to solve for R. R is weird. R is weird because it's going to be something. What part? Denny, which part? Tell me which step so I can see. There's 5 steps here. Which step? The 2.4142. This part here? R plus R root 2. This part here? Oh, the top. Okay. Okay. What does this equal? What does that equal again? The whole thing. Focus on that, people. What does that equal? The thing I just drew. What does this yellow thing equal? What did we say that was equal to? 5. Thank you, Liban. And what I'm saying here is that if you do 2 steps out of it, then that step and that step equals 5. Is that better? Now do you see it? The 2.071, don't know how you got it. I divided both sides by this number here, Denny. I divided 5 by this number. That's an easy fix. We can fix that quickly. Yeah, just isolate R. Okay, I think we're good, people. I think we're good with this question. So there's D. All good to go. Whenever you get a question and it says find a diameter, don't. Find a radius. If a question says to find a diameter, you're better off just finding the radius first and then doubling the answer. Because the radius is a smaller building block, and it's easier to work with smaller building blocks. This right here, I just made root 2 a decimal. I typed that on my calculator. Okay. In fact, this pattern here, where it says a root 2, you could just say 1.4142a. You could just write that. But I prefer to write root 2 because it's more efficient. So this pattern here, this pink thing here, I'm gonna do some magic with you as we go to the next question. I think you suspect what I'm going to do at this question now. Do you see it? So let's take a look here. We have a 2-inch square. So this is 2 inches. I'll just put 2 because it's kind of hard to read that. That's 2. And you want to fit 2 equal circular plugs. And the question is find the diameter D. If you're wondering, the question says exact expression. I'm not showing you exact expressions in this class, but for those students that are able to find an exact expression, that's fantastic. If that were the case on a test, I might even give you a little bit of a bonus on a test. Like nothing too amazing, so not worth your time to do it on a test. But if you have time left over and you wanna flex your skills there, go ahead. So anyway, the question is to find the radius of one of these plugs. So we can actually just use the same technique. So remember, can someone tell me what this length here is? Oh, that's not easy anymore. We don't know that, do we? We don't know that. But wait a second. Could we use the 2's to get that? Can you tell me it now? So what is this length here from top to bottom, like that, diagonal? What's that diagonal length? Anybody have an answer for that? What is the length of my diagonal for this square? You can use the Pythagorean theorem because that's all it is. Yeah, that's right, Donato. Donato, you're correct. Donato's answer is 2.8284. If you don't mind though, I'm gonna write this. But what I wrote on the screen here, 2 root 2, is exactly what Donato has in the chat. So I'll just write it over here, 2.8284. Thank you very much. So that whole thing is 2 root 2. Now what I want to do is I want to write the question in little pieces and do this pattern here. So instead of having the full diagonal, I'm going to break it up into little pieces. And that's exactly the next step in the question. So here we go with that. So here's the shape where I've kind of chopped it up into little R's everywhere. But I think you can get a sense of what's happening here. I'm going to get rid of the wording of the question. We don't need that anymore. What did I just do? There we go. That was awkward. Okay, there we go. So now we can focus on all these things here. You see, I've labeled R everywhere I can. I used uppercase R here. Say whatever. You can use lowercase or uppercase. It's fine. But I've labeled R everywhere. So if we're going to do a little bit of an inventory, we know this is R, and this is R, sure. But then it gets a little bit sketchy because we need to do a root 2. See this here, this pattern? That's this thing right here. Same thing with this one here. So this line segment here that I've drawn in green is r root 2. And then this line segment here as well is r root 2. So there you have it. You have this length here, which I've highlighted in yellow all the way down. So that number there is 2 root 2. That length is 2 root 2, but this length is the same thing. So I'm comparing the two highlighted regions in yellow. Hopefully that is clear. Let's get that bolded out there. Okay, so when you compare the two lengths, you almost have it in your lap there, in your hands, okay? So we're going to have the following. Remember, there's four things here. There's 1, 2, 3, 4 things we have to add together, which are r root 2 plus an r, that's the middle ones. And then we have another r root 2 down below. And that equals what we had earlier from Donato, which is 2.824. But I'm going to put our 2 root 2 there temporarily. So there's your number, 2.8284. And over here, I can replace the root 2. We did that earlier with 1.414. What was it, 4142? Remind me. The extra digit. Thank you, Liban. Thank you. Thank you, Shalon. And then I can go 1.4142. There you go. All right, I'm coaching myself. So that's when you know we're in a good place, when the prof is coaching himself. Anyway, you need to add these all up. So remember, there's a 1 here, and there's a 1 there. So we have 1.4142 plus 1 plus 1 plus that. So that's 4.8284. And that's r equals 2.8284. Can someone confirm they agree with these numbers? Thank you. Don't worry, I'm just going on autopilot for a second here. I'm just writing down the easy stuff while you're confirming that I do math correctly. All right, can someone give us r? Let's give me r here. What's the r value? Thank you, Denny. Thank you, Liban. What is the r value here? What is that divided by that, please? .5 something? Can someone give me a decimal there, please? 4 decimal places, hopefully. Oh, thank you, Shalon. So 0.5858 inches, okay? And then we have d equals 2r, which I'll just double that answer and get 1.172 inches. There's the answer. There you go, my friends. Do you see that this question and the previous one really tied together well? And hopefully, do you see that there's a more of a pattern recognition that's happening now? It's like you're comparing pictures, and this little root 2 pattern for the diagonal of a square is appearing in multiple instances. Because if you got that in your mind set up, then you're ready and really can make sense of the next questions. Any questions involving circles within regular polygons like squares, or even if you had like a hexagon or something weird like that, you can follow similar steps by constructing little rectangles or little squares or other inscribed figures for those circles. So I said to you that the pattern that we started off this hour of class with applies to even the next question. Yeah. The good news is, though, they're very limited in terms of what I could ask you, like in terms of these patterns. But what I do want you to see is that they're practical. This question here is very practical. this could be a cross section of a wall, and you want to fit two conduits through it. Perhaps you have a drain and a water supply, and then obviously you wouldn't put them this close to each other, but you have something where you have to fit two conduits. Or maybe you have an intake and an outtake. Like if you're talking about a supply of air to a closed facility, and you want it to have that whole ventilation kind of the ductwork nice and neat. Yeah, so each circle is 1.172. That's right. Let's put that here. Okay, I'm going to move on to the next question. Another very nice practical one. In this case, we have something interesting happening. We have a patio. Actually, thanks for reminding me. I left my cocoa on in the other room there on the kitchen table. So just read this question for a minute, and we'll start taking it up. So in this case, you're trying to fit a circular patio into a square region, but there is a constraint. We have this triangular corner here, which is interfering with how much space we have. This doesn't have to be a patio. This could be another cross section. I know that like this is not an HVAC class, but let's say this was HVAC, right? You could have like you want to put conduit through a wall, but this time there is a structural piece here that's blocking it. So this part of the wall is off limits. You can't go through that cross section for whatever reason. Maybe there's a joist in the way. Maybe there is some type of bracing or something that is already that already exists there that you cannot permit a larger circle for. Whether it's a patio, a hot tub, or a conduit in a wall, we can still do the question because we're smart. So let's do the question. So I'm going to get rid of the wording here. And, well, what the heck did I just do there? There we go. Okay, so let's talk about that figure. Now, if you'll allow me here, the shaded region, the hatching here, it's a little bit annoying. So I'm just gonna show you my modified diagram. So here's the modified diagram. Let's just zoom in a bit. So you see the pattern there. Before we start exploring the pattern, can someone tell me what this length is? Top to bottom, like that. What is that diagonal equal to? I'll give you a clue. It's the same as the last question. Yeah, it's 2 root 2. Thank you, Shalon. That's 2 root 2, or you can put a decimal there if you want. Why is it 2 root 2? Because very convenient. I've given you the same framing shape here, although this is in meters, not in inches. Same shape though. Now, that's the entire journey. Now let's do the journey with baby steps. We're going to go here, and then we're going to go here, and then we're going to go here. So 3 baby steps. So let's do the first, let's do the easy baby steps. Now what's funny here is the baby steps that are the easiest are the ones that you've seen already. I know that that length there is R. It won't be, I understand what you're saying. It actually, the ratio is not as easy as 1.5 though, sadly. But what you have there is a pretty good estimate though. So there's my other thing there, the other rectangle, sorry, square. And I know this length here, the diagonal is R root 2. Notice that what took us like 5 minutes to talk about with this R root 2 earlier and had several students requiring clarification. Now it's like I just drop an r root 2 on the picture and you're like, oh yeah, that thing again. And that's actually what it is. It's just that thing again, because we've done it 3 times already with the introduction and the 2 exercises that we worked through. The only thing that we haven't resolved yet, because this is actually 3 segments here, 3 line segments, we need this one up here. So this one up here is a little bit funny, and I'll show you how you do that, and then we can move on. So you can do this different ways. What you could do is draw a little square in here. You can do a little square in there. And that's actually the way that I would do it personally. So if you do that little square there, let me draw it on the outside here because I don't have enough room for it. I know that this is a half and this is a half. Can you let me know in the crowd there? Why is that a half? Why is that a half? I'm saying this thing here, I'll just take it off like that. Yeah, because of the 1, that's right. Because this is 1, and this clearly due to symmetry, there's symmetry there, we have half. So this is half, and that little piece there is half. Thank you very much. So, oh, what's that pattern? The root 2 thing, right? So this is going to be half times root 2. There you go. Well, my friends, congratulations. Because this thing here, and this thing here, where the first one is over here actually, is equal to this. So we have the orange line segments equals the blue line segment. We can make a formula out of that. I won't get that far ahead, Denny. I'm gonna see what it is. I think the pattern is not as clean as you might think. Having issues typing today for some reason. Okay. So I need some support here. Can you give me this on your calculator? I need 4 decimals, 5 decimals. Let's go 4 decimals is fine, actually. It's fine. 7071 plus R plus 1.4142 R equals, what was the other one, the big one? We did that one last time. I'm going to cheat here and look over on the side. 2.8284. Okay, so in this case, you need, I'm going to move the diagram out of the way. We'll zoom out here. Let's get this 7 here, this 0.7, and move it to the other side. Also, let's take these r's here and combine them into a single term. So we're going to get the following. 2.4142 r equals 2.8284 minus 0.7071. Can someone subtract those? I know that's ridiculous for me to ask, but just please do it so we can move on here. 2.1213, is that correct? Please confirm. Thank you. Sorry, I'm asking you for very easy questions. Just want to do my due diligence here. And then if you double that, you get 1.757. There you have it, my friends. Look at that. Another question down the pipe. Yes, Shalon, what's up? What's your concern? At the top, how do you get the 2 square? Be more clear. I'm not sure. Are you talking about the left picture or the middle picture or the right picture? Or are you talking about this thing here? This one here. It's the blue one. It's this blue thing. It's the blue line.
Sir, if you're moving the 0.7071 from the left to the right, you're subtracting. Wouldn't you add it on the other side?
No, you're subtracting because it's positive. It turns into negative.
So if it's positive on one side,
When you move it over, it becomes negative
okay, why does it become a negative?
because you subtract that number from both sides. You need to subtract this number from both sides.
Okay, so what you do to one side, you gotta do it to the other side.
Yeah, and Shalon, your comment is correct, Shalon. I'm gonna get to Ram's question in a second. Ram, could you give the distance OC? Are you asking about this distance here? Explain it, you mean? Explain that. It's the pattern that we saw before. I'll draw it on the side. So let me highlight, let me just take that thing on the side here. This is to Ram's comment. So we have that little square there. This is R. This is R. There's a right angle there. There's the right angle. And then we know the diagonal, the pattern that we started this hour with. It's the same pattern. It's R root 2. Remember the pattern we talked about at the beginning of the hour. So that's this shape here, okay? Got it. How did you get 87? 87, I took this number and I divided it by this number. I can write that down actually. All good, George. I got you, buddy. Don't worry. There you go. You're welcome. So I want to do one more question with you, but I'll just give you another 30 seconds to process. It's actually kind of funny because when I first started teaching at the college, the third line of the equation, right here, I took these two numbers here and I added them together, the R's, 1R and 1414R, to get 2414R. And then I took the 0.7071 and I moved it to the other side. You're welcome. So when I first started teaching at the college, that is probably about, let me see, I've been to college, this is probably my 9th year now at the college. And one of the first courses I taught was like this course. It was a different name, of course, but this chapter, in some way or form, appeared in that course as well. So I was given the booklets from my predecessor and my mentor at the college. He's retired since. And it was kind of funny. They go, oh, just, do all the questions, see if you can teach it. It shouldn't be a problem, whatever. So chapter 6 comes along, and I was just slicing through all the booklets like it was nothing, which is a good thing. That means that you're in good hands. Like your teacher knows what they can answer the questions at least. But this booklet here, when I got to question 17, in the entire course, question 17 was the question that took me the most time to do. I was able to solve it. It wasn't about solving it. It was about finding the cheapest, easiest, most efficient answer that I could explain to an audience. Because honestly, you can answer this question and it might take you a lot of time. So the good news is I have come up with an answer which is very, very cheap, and hopefully you'll understand it and it won't take us too much, give us too much stress. So without any delay, here's our last question for today. In this case, we're going to take 3 circles and we're going to put them equal circles, and we're going to put them inside an equilateral triangle. Remember, equilateral means that all the sides have the same length. So there's a lot of symmetry happening here. Our objective is to find the diameter of one of these little circles. We're going to find the diameter of one of these little circles. As I mentioned to you in the past, when you want to find questions involving circles, it's better off to just find the radius. So I'm going to move the question over here and get it out of the way. And I want to focus on this diagram, because what I'm about to do is going to be very, very clean. So let's take this picture and let's have some fun with it. That's part of it. You are definitely going to take advantage of symmetry here. Whoops. Ultimately, you're trying to find the length of the radius or the diameter. So I have a question for everybody. What's this angle in the corner here? Can someone tell me that angle? How much is this angle? How did you get that, Jifeng? Very good. I got a mic there, but I can't hear anything. Can someone mute their mic, please? Sorry, I got audio in the background. Can someone mute their mics? Thank you. Thank you, Denny, as well. 180 divided by 3. So here is the key to the question without delay. This is the right angle triangle I'm going to use to solve the question. This is so sensitive, this cursor here. There we go. Sorry? Where did the 3 come? What 3? There's no 3 here. Oh, the 3, it's because they're equal. This is all triangles add up to 180. This is 180. Shalon, that's 180 degrees. Remember all the angles in a triangle? Add up to 180. So this is 60 because they're all equal. Here's my triangle. This little thing in the corner here is my triangle. Now someone mentioned to cut the picture in half. I'm going to do that as well. There, I've cut the picture in half. What's this length? In the chat, let me know. What is that length there? 1. Very good. What are we trying to find in this question? We're trying to find the diameter or the radius. Because they're all the same, Shalon, they're all the same. These angles are all the same. It's equilateral. Cool. So let's get back here to business. This is R. That little height there is R. What's this angle in here? What's that little angle in there? That's correct, George. Very good. So we have another angle bisector. Okay. One more thing, and I think we're good to go, people. One more thing, I think we got this. Can someone tell me what this is? What's this length here? How much is that? It's not a number, it's a variable. It's R. Thank you, Ram. Ram is one step ahead. That's R. So then this length here, this little thing here, is 1 minus R. So let me highlight that in yellow. I'm getting feedback on the mic. I'm not sure if anybody has their mic on right now. Please turn your mics off. So that's 1 minus R, because this is 1 and this is R. And you have to subtract them to get this. You're welcome. So, my friends, we are almost done the question. How exciting. We have, whoops. We have a sine of, no, tan, my bad, tan. Tan of 30 equals r over 1 minus r. And we end with a question today that's very similar to the algebra that we started with. Well, definitely, this is not a question that I would deem to be easy. My original answer was brutal, but now hopefully this version is a lot easier to process. At this point, guys, we're gonna just go with some calculator work. Can someone give me tan 30 on their calculator? 4 decimals. Thank you. And then we're gonna cross multiply. And then we'll distribute. So just walking you through the motions here. We have the 0.5774. Sorry, can someone turn their mic off? I'm asking again. All right. Sadly, people have muted everybody. I have muted you all. You are not allowed to speak for the next 2 minutes. I don't know whose mic that was. Anyway, I've distributed the 0.5774 into the brackets. Let's move that to the other side. Okay, can someone do some calculator work here with me? What does R equal? And what does D equal? Thank you. Can you give me an extra digit there, Shalon, if you don't mind? Thank you. I guess the final answer is? Thank you, Liban. Okay. That was a fun little question. Hopefully you enjoyed it. Didn't give you too much heartache there. But yeah, that was a great class. I hope you had a lot of fun today. We did some tough questions, but we're gonna do easy stuff next time. We're doing surface area and volumes next time.